Welcome, chemistry students, video 7.6. We are now going to determine chemical formulas. Basically, in this video, we want to talk about the symbols evaluated of a chemical formula. So we're talking about the elements and the subscripts, looking at their empirical formula, get the definition of that one, molecular formulas, take a look at that definition, and even the structural formulas, which you know a little bit about already. We can only determine an empirical formula from a percent composition or mass composition. So you need to know how to get percent composition or mass composition, which we should have looked at already in video 7.5. And our last objective is to take a molecular formula from an empirical formula. Basically, we need the definitions here. You need to know empirical formulas account for the composition of a compound in terms of the relative numbers and kinds of atoms in the simplest ratio. Need to know it's simple. Molecular formula, chemical formula that shows the exact number. So pause it, write these down. Here's what you need to know from it, is that empirical formula is a simplified version of the molecular formula. Down here we have some examples. If you're taking a look at them, we have the empirical formula and molecular formula for water. It's the same thing. There's its structure. This is a space-filling model, which we've talked about before. A little different than the ball and stick model. Hydrogen peroxide, however, though, its empirical formula is different than its molecular formula, because the molecular formula is the exact formula. That's what the compound looks like. The empirical formula is simply the simplified version of it. So, how do I simplify this? Well, look, both subscripts have the 2 in them. Let's do the least common denominator, divide both by 2. I end up with just an H and an O. Same thing happens here with ethane. I'm going to divide both of those by 2 to simplify it to get my empirical formula. Sometimes, though, compounds here that have the same empirical formula but a different molecular formula. That means they are different molecules. Look, formaldehyde, the stuff that you keep in a biology class, that brown liquid in the jar that smells really bad, you know, if you did any dissections, that versus acetic acid, which you probably eat sometimes in a lot of your foods. Supplement. Empirical formula, formaldehyde, CH2O, CH2O for acetic acid. Well, comparing those two, they're the same. Definitely do not want to be eating formaldehyde though. That's because its molecular formula a little bit different. It is different here. The reason being is because the compound of acetic acid is simplified. I divide each one by 2. I just end up with the simplest ratio of that compound. So there are things that we need to do to make sure that you're not eating formaldehyde. Let's look at how we do that. Basically, get these steps down here. Pause the video, write these down. The empirical formula has to be determined from the molecular formula. So if you are given here 100% or 100 grams of the substance, always assume that you're given 100. Convert percents to grams if you need to do that. Use dimensional analysis to convert grams to moles. Divide by the smallest mole ratio. Basically, that's you are the weakest link. Divide by the weakest link. And we're going to look at what that means right there. That's a very important step. Maybe you should circle this one right here, number 4. No, number 4, okay? Important one to know. And number 5 here, you are going to take a look at a whole number is not found round using these rules. We're going to look at that and see exactly what I mean. And this will all make sense in the example that we work out. So, number 5, you are going to follow these rules if you do not get a whole number. And here's what I mean. If a number has one of the following decimal places, so 0.17, 2533, 56, 0.75, it's basically a fraction. You're going to convert it into a fraction, and then multiply each of the mole values by the denominator of the fraction. So the denominator is always our bottom number. And then assign the answer as subscripts. So what do I mean by that? Well, look at this example here. Let's say you work out your empirical formula and you get these answers, 1, 2, and 1.33. Well, this is not a whole number. That causes problems. What we need to do is see that the 0.33 is equivalent to 1/3. So what I'm going to do is take the denominator, 3, and multiply it right here by each number. So 1 times 3 is 3. 2 times 3 is 6. 1.33 times 3 is 3.99, basically 4. All of those are whole numbers. These numbers become my subscripts, so it becomes Ca3, 6 for oxygen, and H4 because that's my subscript. So again, get this down. So let's take a look at this example here on how to calculate the empirical formula. We're giving this compound NutraSweet. Has 57.14% carbon, 6.16% hydrogen, 9.52% nitrogen, and 27.18% oxygen. We need the empirical formula. Reminder, that's the simplest formula of a compound. And our first step here is to start with the number of grams of each element. Well, we are given percentages. So we have to assume that there's 100 grams and that the mass of each element is going to be equivalent to the grams. So my first step here is to take my percents and make them all grams. First step. Second step here is to convert the mass of each element to moles using the molar mass. So I'm doing a gram to mole conversion for each one there. So go ahead and maybe jot this down in your notes if you want the step-by-step ways. Grams to moles. My next step is going to be to convert all of those into the whole number that's going to represent my subscript for the compound. This is where I say divide by the weakest link, and I'm looking for here the weakest link. So I'm going to divide by the weakest link. And what I mean by that is I pick here the 6.68 is my weak link. It's the lowest mole number that I got for each mole conversion. So I'm going to divide each by my weakest link, and I'm going to get my subscript here for my compound. This is going to be my subscript. Now, the only problem is this guy right here. That's an issue. I cannot have 2.5 oxygens. I cannot have O2.5. That is a big no. So what do I need to do here is to multiply by my multiply by as a fraction. So I know that 0.5 is equivalent to 1/2. So I'm going to multiply each one by the reciprocal, which is going to be just 2/1. And that's really detailed here in the next step. If you take a look, this is where I end up multiplying by 2. So this mole ratio is represented as a subscript, which I was explaining there. If it is too far to round, so it's not close enough to the whole number, then you have to multiply each by that factor, which if you remember in our notes, we looked at those examples. So that's where you're going to refer back here to your notes and our sheet here. Remember that if each one is like 0.5 is going to be 1/2, I'm going to multiply by 2, and that's kind of what I am talking about in this example. So this is demonstrating I multiplied by 2, by 2, by 2, by 2, because it's too far to round. I'm halfway there. So I end up with 14 carbons, 18 hydrogens, 2 nitrogens, and 1 oxygen for an empirical formula of C14H18N2O5. And that is NutraSweet.